we have actually gotten sort of like things started today. What we're going to talk about today is turning forms in space is sort of like the title of what's happening right now. And what that means is that up until now, we basically have drawn the same exact forms over and over again. We've drawn a cube, we've drawn a cylinder, and we've drawn, all these basic forms from one angle. Today, we're going to talk about how you turn those angles and change what like the actual angle that you're seeing. How to begin thinking three-dimensionally. Like I said, this is about drawing forms from different angles, being able to turn a cube, a cylinder, a cone into space. So far, when we learned how to draw a form, I gave you one basic form. You just draw a square, like a perfect square, and then you draw parallel lines coming off of that square in every direction. You make sure that every line is parallel to its opposite angle, and then that's how you basically make a cube. And then we talked about how to make cylinders, and then you make cylinders with ellipses and how to make those ellipses look like they're three-dimensional. Today, we're going to talk about two new concepts. The first one is foreshortening, which is dramatically shortening or reducing to convey basically like perspective to the viewer, meaning like you take one angle and you make it smaller than another one, and it makes that angle look like it's changed its view. And then perspective, literally, is when if lines are not parallel, then they recede. And we're going to talk about what that means, because everything that we draw when we're drawing just basic forms, we use parallel lines. But when we start drawing like in larger space, then we start talking about foreshortening is what I'm going to sort of focus on for this sort of demo here, and kind of talk about what it looks like when you have a cube and you change its angle, or you have a cylinder and you change its angle as well. And I'm just going to kind of touch on some of the other things as we get towards that as well. This worksheet right here is uploaded onto your classroom, because when you're done with this, when I'm done talking about this, these are your references to draw in your sketchbook to add to your other forms. And you can do your own if you find your own on the internet as well, but I wanted to have sort of like things for you showing the example of exactly what we're doing here. That when we're drawing a cube, we can draw a perfect square, and we can bring these parallel lines off the side of that square. As long as these are all parallel to each other and to the original lines that we drew, we'll make a perfect cube. This has not changed. When we change the way a cube looks in space, this rule still applies, but we don't just start with this shape like this, right? What we're looking at is here's a cube, and if we turn the cube like this, then basically the angle that we're seeing is, like, it'd be the way around, there it is this. Like, this is the cube that we're seeing right there, is this cube right here, right? Well, what happens if I take this cube and I turn it like this, right? Well, now these two things are the same size as each other, or maybe I keep turning it even more, and now actually the ones over here are even a little bit smaller than the ones over here. So this is that foreshortening thing. Like, watch this little angle right here. The more I turn it this way, visually, the smaller this little part right here gets, until actually, when I get right here, it disappears. And then as I go back this way, now this side starts to appear and gets bigger and bigger until they're the same size. And then they switch until this one disappears and it's gone. That's what foreshortening is. Okay, so how do I draw this? How do I represent this as a drawing? So to actually make this happen, I'm going to show you some things that we can do. So when we're drawing a cube at any other angle that isn't just this basic angle like this, instead of starting with a perfect cube, what we start with is the angle that we perceive being closest to us. Meaning, if my cube looks like this now, right? This guy right here, this line down the center of my cube, is actually like the closest to me, right? If I like took this to my eye, these are further away and this is the closest. So to draw this angle of cube, what I do is I start actually with this line here, right? And then what I'm going to do is I'm going to bring these angles this way, this angle this way as well. And then from here, I'm literally copying the same rules that I taught you guys earlier. Okay, I need to make all my lines parallel to each other and all my angles. So here's this one right here at this straight line. So I need to make sure that right here, I draw that same straight line. Now I'm going to take this line right here and make sure it is as straight as this line is right here. Now I can do it on the opposite side. This is my line here, so my opposite angle needs to be parallel. There it goes. Now I need to make sure this line and the line I'm about to draw here are parallel, and then this line right here and this line right here. And I actually just looked at this one right here after I drew it and realized that I could actually probably go down just a little bit. So I'm going to do that. And that's how we make it look like that we took this cube basically and we pushed it this way. We actually took it and spun it from that angle to this angle, right? Now what we're looking at is kind of more or less this angle, give or take that I wasn't perfect on proportions, but I am on. or what you foreshorten when we're talking about cylinders and things that use ellipses. And if you guys remember, an ellipse is that not a circle that we talked about here, right? This shape right here, it's this space right here. So what we play with is how much of a circle it looks like. So if I want to draw a cylinder, right, here it is straight up at my face, it is a perfect circle. The more I push it back in this space, the more of this part I see, and then the more or the less of this part I see. So as this part gets smaller, this part gets bigger until it changes the size, right? So now this is my smaller size and this is my bigger size. So let me show you that like as a drawing. So here would be, you know, literally just top view of cylinder. I'm just looking straight down at it like this. Now I take it over here and I turn it back just a little bit more. And now I turn it even more. And that's how I change a cylinder to make it feel like it's actually turning this way or that way. Okay, so it's all about how big this space is right here, closing up the space right there of your ellipse to make it look like it's at a different. Okay, so those are your two techniques. That's a rinse and repeat kind of thing. You'll use that for every single thing that you draw. If it's a cone, if it's a cube, if it's a pyramid, the only thing you're not going to be able to draw here is a sphere, because nothing happens to a sphere. A round ball turned in space is always a round ball. So you just make sure you use these other ones that I placed on this worksheet itself. But you're basically going to add 5 forms that have been turned at a different angle than the basic front angle that we've been drawing. You're going to add those to Wednesday's drawings. So on Wednesday, you drew 11 forms, 10 fast and 1 slow. You're going to add 5 more to that, which means altogether you're going to have 16.